This video, we're going to graph some linear equations. So we can use a graph here to represent the linear model that we're making and get a better idea of what we would call a forecast model, something where we're going to project maybe several years into the future, or maybe even several years into the past if we're trying to make a model that will tell us what happened in the past. Let's go ahead and make our model here using the same techniques that we used before. The cost of tuition at one community college is $300 plus $125 per credit hour. So T for tuition cost is going to be that. Graph the equation. 300 plus 125x. And we want to set our window here so that our x min is 0. Our x max is, it looks like 15. Our x scale is in ones. Our y min is 0. Our y max is 2400. And our y scale, our tick marks are in amounts of 200. And we're going to graph that. Let's go ahead and let's look at my table here. And let's set this back to auto. We're not interested in negative data points. So we have 0, 300, which is halfway between 200 and 400. Then we have 1, 425. And then we have 2, 550. And then we have 3, 675. You're starting to see this linear model grow here. If I could find some points though that were exactly multiples of 200, that would be great. So let me get 4, 800. And let me get 12, 1800. And do my best to connect those dots like so. And this should come back down here through 300. And there's my linear equation. It doesn't make any sense over here. Not sure that I can erase pixels with this. No. So it only makes sense up to right there and then stop, because we can't take less than 0 credit hours at the college. It also stops making sense once you get to full-time up here, which is like 15 to 18 credit hours. That is usually a maximum that they let the student take per semester. So our X should probably be restricted in domain between 0 and 18 credit hours for this model. Once you start going over that, then they start making you pay extra, usually to take extra classes. During the month of January, the depth of the snow at the base of one ski resort decreased by 2 inches each day. So depth of snow on December 31st, there was a base of 63 inches. Graph the equation, use the graph to estimate. Okay, so day 0 here, there was 63 inches, and we're losing 2 inches a day. So that means that on that really means that here we should be at 61, because December 31st, we were at 63. We're on January 1st, which this is a model for the month of January here, we're going to be losing 2. We would be at 61. So our y-intercept here should be 61, but let's call December 31st day 0, and let's call day 1 January 1st. So we'll call this 63. So we're going to call this December 31st here. Then that's going to be January 2nd, January 4th, all the way out to, there's not 32 days in January, but you get the idea. So let's model 63 minus 2t. And we've got on day 2, it's 59. On day 4, it's 55. No, 50. Yep. On day 6, it's 51. So on. So this looks like the model right here. Let's see where it crosses the x-axis out there. If it does. At 30 days, it's 3. And at 32 days, it's -1. Best to draw a straight line here, like so. Okay, we want to estimate what's going to happen on January 28th. So D28 is going to be about 7 inches. January, yeah. And that's just for my model here, that the way that I set it up was that x equals 1 was January 1st. So x equals 28 is January 28th. And our depth there is y. So we'll have 7 inches of snowpack left if they are losing 2 inches a day. And they started with 63 inches on December 31st. I think that is my last, yes, that's my last model for this section. So main things from this, remember your slope intercept form. I'm just going to write that out again for you, that y equals mx plus b. Remember your point slope form. And remember your slope formula. Those are your 3 big formulas for this linear modeling section. All right. See you for the next video.